Hi guys, it's me, James at Drayton. Welcome to tonight's Facebook live stream where we get a chance to talk about some Drayton products and answer your questions. And tonight, the gist of tonight is going to be about how to drive some efficiency out of your customers' systems. It's really in response to some questions I've been getting recently from some customers who, you know, they've sort of held off turning on their heating system, and it's now getting, I think it was 6 degrees here in Plymouth today. So people are starting to think about turning their heating on, and you know, they just want some tips and tricks. And a lot of what they're really looking for at the moment is how to really drive their efficiency. They want to turn their heating on, but you know, they don't want to be spending a fortune on controls, but they want some tips on what they can do. And also, if there's anything that, you know, is reasonably inexpensive for them to do to drive that efficiency, that's really what they're asking of me. So that's really what we're going to cover off tonight. But that's not to say we can't talk about whatever you want. I'm going to be here for about the next half an hour. So anything that you want to talk about or ask of me, stick it in the questions in the comments, and I'll answer it. But what should we look at first? Balancing, I think. So I'm not going to talk to you too much about balancing on the principle of it. You know, you all know that. But just in general, you know, the whole principle of balancing is we're trying to make sure that we're getting adequate flow to each radiator on the circuit in order for it to be able to emit that thermal energy that's being carried by the water into the room. So it comes down fundamentally to having the right size radiators, you know, and the right pipe size so that we can deliver that flow. But what we can then do is provided that we're getting enough, we've got the capacity to get enough flow there, then what we really want to do is we want to make sure that there's no one radiator getting too much flow, thereby robbing the heat from other radiators on the system. So that's the whole principle of balancing. The way we do it is by throttling down apertures. So, you know, traditionally you'd have done it with the lock shield, and you would have turned your lock shield down and done your differential temperature across the flow and return, and that's fine. And you know, that's a perfectly valid way of doing it, but from an installer's point of view, quite laborious, quite long-winded, and that's why we've now got things like the auto balancing TRVs. But I'll just run you through the old way of doing it. Now, obviously, if you're doing it with a lock shield, you'll have a fixed flow rate body, TRV, and on the lock shield you'll throttle down. Now remember, this is the EB body, so this is the body that you get with the TRV4 and the RT414. Now you can actually balance on this. Now this is not auto balancing. What you're doing with this is you are setting a fixed aperture size. So if you look at the output there, if that shows up, you can see down inside there that we've got a very small aperture, and we can change the size of that aperture by rotating the valve insert. So you need our presetting tool, or the balancing key, and you just insert it in the top. Now you can do this on a live system. You don't need to drain down or anything. This can be done when it's filled. So you loosen off the locking ring at the top. Now you only want to give it about a half turn, so just go 180 degrees. Flip the tool over. Now you see there's two prongs on the end of this tool, and they engage in the top of here. And so once you're there, you've then got numbers around the top, and you align the number with the output of the port, or the port that's feeding into the radiator, and then you've got 6 positions. So again, turn it in a clockwise direction, just so that if it picks up the clamp ring, it will all it's going to do is tighten it. We don't want that clamp ring coming right out, because if it is, it's only the friction of the seal, the main seal, against the actual casting that's stopping the insert coming out. So it can turn into a projectile with 1 bar of pressure behind it. So you definitely don't want to be taking it all the way out. So just turn that around to your to the setting that you want. Now on the inside of the box, you will see the different flow rates, and you'll be able to see what flow rate you need. So you can still do it that way, or you can use your differential thermometer across the flow and return, and then you're just fixing it. But the reason this is good is you would leave the lock shield wide open. So once you've set your position, so in this case here, let's say I want it set to position 2. Turn it clockwise until position 2 is in line with the port, which is there. And then when you put the TRV head on, so turn tighten your clamp ring down so it all goes nice and rigid. We've got position 2 in line with the output port. That's really considerably closed off that aperture there, which is already quite small. I think it's a 6 mil hole in the casting, but in position 2, we're looking at maybe a hole of maybe 2.5 millimeters. And then we can put the TRV head onto here and leave the lock shield wide open. And it means then that it doesn't matter if they take the radiator off the wall or anything, they're never going to destroy the balance, because the aperture size is set by you turning that insert. So it's a perfectly valid way of balancing, a good way of doing it. It has now been somewhat superseded by our auto balancing TRV, which is this one here. Obviously, this is a straight version of it. But the main difference being, let me get rid of that wiser head. The main difference being is when you turn this insert on here to a position, it's a fixed aperture size. Now, if you get changes on the system to pressure, and that will be a function of temperature, you know, as everything starts to warm up, other TRVs start to close down, your pressure on your system will rise. We're not actually fixing the flow into the radiator. So when you balance with these, you're only really balancing at one point through the sort of heating cycle, you know, either when it's warming up or when everything's heating. But then things are going to start to throttle down other TRVs, pressure's going to go up. You're going to end up getting more flow through this into the radiator than it needs. And that's the same if you do it with a lock shield. If you do it with a lock shield, you're fixing that aperture size. What we really want to be doing is we want the aperture to be dynamic, so that we set the flow rate that we want into the radiator, and then regardless of whatever happens on the system, if the pressure starts to rise, you want an active element in here that detects that pressure rise and stops the valve giving excess flow to the radiator. And the way it does that is it starts to throttle down. So you set a baseline of the flow that you want into there, and then you've got a little pressure independent sensor inside which will manage the flow into that. So these come with the TRV4 and the RT414. So you can see here, this is the straight version. That's essentially what we've got here. And the heads that go on the top of these are exactly the same. So it's exactly the same heads as you would get on the EB body. So they are interchangeable. Really good if you're fitting Wiser. You know, you haven't got, if it's a new installation of Wiser and you want to, you need valve bodies, stick the auto balancing ones on there, because it makes balancing so much easier. So let's have a look and see what we actually get inside of here. So this is the 15 mil angle. 15 mil angled and straight is what's available. So there's your angled body with your dust cap on the top of there, your decorator cap. So don't throw that away. You'll need that, because you'll note with these, when you turn them down to minimum, all you get is the frost position. So if you actually want to turn these off, you need to remove the head and install the decorator cap, and then you can screw it all the way down. It's a brave man that relies on, even when these have got an off position, I still don't trust them not to leak. So it's good practice to always stick a decorator cap on there. You'll get your tail that obviously goes into your radiator and then allows you to fix it onto the radiator. And then you get the lock shield that goes on the other end. The lock shield with these, incidentally, just like the EB body, if you're balancing on the EB, you will leave this in the wide open position. So still lock it, because we don't want people to inadvertently change it, but you want that to be as wide open as possible. And then what else is in the box is the olive and nut that goes on the bottom to take your tail that's coming out of the floor. So looks pretty standard, and one of the key features of this is the fact that it is dimensionally the same size as our other body. So normally with auto balancing, the bodies tend to be bigger. You'll have a much more of a projection on one of the ports. Well, not with ours, it's exactly the same size. So you can easily swap them out. It's exactly the same radiator tail. The only difference is they are unidirectional. Now you can see here, if I get the glare right, you could see the single-headed arrow there. If we contrast that with the EB body, you can see you've got the double-headed arrow. So the EB body, and you know, it's most 15 mil angled bodies that you come across now, you expect them to be bi-directional. The auto balancing ones can't be. These are unidirectional, which means you have to respect the flow direction arrow. It's always been the case with the straights. The straights have always had an arrow on them to show you which direction the flow has to go in. And it's really important that you respect that flow direction. If you don't, you will find that these, firstly, don't give you any heat, and secondly, can be noisy. So you've got to respect it. What that means is when you're going to fit them, kick the heating system, kick the heating in, and you know, if it's a retrofit, and just go around and don't just blindly fit this in place of where the current TRV is, because if it's a bidirectional body that the TRV is on, then it's not necessarily going to be on the flow. These don't have to go necessarily on the flow, but if you want them to sit in this orientation, which most people are used to, where you've got the head sort of perpendicular to the radiator, so it sits vertically. If you want it to sit like that with the auto balancing body, it has to go on the flow side, because the flow has got to come up out of the floor and then go into the radiator. If you want to fit them on the return, you absolutely can do, but you can't fit them in this orientation, because otherwise the water's trying to go out of the body and into the floor, and you're going against the flow direction arrow. So if you want them to go on the return, they've got to sit in this fashion here. So sit them on the side. Now, that's perfectly fine. It doesn't affect the sensing, and you're absolutely at liberty to fit them like this if you want. But you know, a lot of the customers prefer to see it this way. So what it means is, if you're retrofitting, it may be you need to swap ends. You know, you maybe have to swap the lock shield with the other end of the radiator, or you know, if the customer's happy to have them in this orientation, well and good. Now, the way we set them on the inside of the box. So if you've got a new radiator that you know what the output of the radiator is, you've got your chart there, so you can choose your the kilowatt output of your radiator, and you can then cross-check this. Now, remember that this output of your radiator will be based on a flow temperature, probably 70 or 75 degrees. Now, if you're running lower flow temperatures, your output of your radiator will drop. So it's worth considering that just because you buy a kilowatt radiator doesn't necessarily mean that if you're running it at a lower flow temperature, you're going to be getting a kilowatt out. And obviously then that's going to impact on the amount of flow you need through it. So you might need to do the calculation to make sure that you understand what and most radiator manufacturers now will give you a chart to show you what their output is at a particular flow temperature. But the headline will always be, you know, if you go into Screwfix and you buy a radiator and it's a 2 kilowatt radiator, that's going to be 2 kilowatts at probably something around 70, 75 degrees. So if you know the radiator output, you can use the chart. If you don't, we've got a handy tool on our website. So if you head over to or if you Google, I should say, the Drayton calculator, you can go through, and if you don't know the output of the radiator, you just measure it, and then you can choose what type of radiator it is, and you've got all your different types there. And then you also pop in your flow temperature, because obviously that will have an impact. And you can see here for a radiator that's 900 by 1200, which is a type 22, so 2 panels and 2 convector fins, you can see the difference over there on the right hand side. Setting of 15 is what you would have for, say, a delta T of 15. But if you want a lower flow temperature, you see the flow goes down. It goes down to 8. So it's important that you take into consideration flow temperature when you're setting this. So that's the auto balancing. You set them using either an 11mm spanner on the hex at the top. You can see the graduations around the top there. You've got your little index mark there. So whatever it needs to be set to, use either an 11mm spanner or our new tool that's got the hex in the bottom of it. And you can just turn that around and set it like that. And if you want to have a quick look inside what's going on, this is actually a cutaway of what's happening inside here. So you can see this is the little pressure independent sensor there. So it's obviously you wouldn't take this apart on a live system, but then you're not going to have this plumbed into a live system because it's going to just leak everywhere. But that's the new insert, and that's the bit that's actually sensing the flow. And making sure that you're only getting the flow that you choose on the top here. So if you set this to, say, position 8, that essentially means 80 litres per hour. Whatever it says on the top, it's 10 times that in terms of flow. So whatever's going on the inlet you're always going to get the same flow rate out of the port there into the radiator. Right, that's enough on balancing, I think. Let's have a look and see if there's any questions come in. I don't see anything at the moment. But if you've got any questions on what you're seeing or anything Drayton related, stick them in the comments and I'll answer them. Next thing we'll have a look at is our new 𝗽𝗍𝗳. Now, these have been out for a while now, so you must have seen them, and they replace this. They replace the wavy bottom 𝗽𝗍𝗳. And remember, there was loads of different SKUs of these because you would buy them if you wanted, say, a 24-hour or a 7-day. But we've simplified that right down, and there are now just 4 different SKUs of the new 𝗽𝗍𝗳. So you now buy it based on the type of application. And what I mean by that is essentially the type of wiring. So if you buy a 2-wire, you buy a 4-wire, or you've got 2 RF versions. So you've got your single channel RF that will replace your 𝗽𝗍𝗳 plus 2 RF and plus 3 RF. And then we've got the 2-channel, which I'll come on to in a moment, because that's quite an exciting one, because that allows you to really upgrade your customer really easily and give them some load compensation. So key features of the new 𝗽𝗍𝗳. Backlit display. It's we've now given the backlit display so you can see what's going on, and we've also got this confirm button here. So remember, with the old one, if you wanted to make a change, I'm not sure what I've done with the old one. Here we go. So with this, the programming was a little bit clunky because you'd have to make your change and then you'd press the right-hand arrow key, and it wasn't terribly intuitive. This is much more intuitive now, where as soon as you make a change, you confirm it with the circle button and it locks that change in. We've also got there's also an audible alert on there, so you can probably hear the beeping. So this is designed for people if they can't use the screen, if they're visually impaired and they can't see the screen, all they have to do is they have to count the beeps. So the way this works is as soon as the ambient temperature matches the set point, so here 19.5 ambient, you get the double beep, and then for every subsequent ½ degree that you move up, you get a high beep. And if you go the other way, you get the double beep as soon as the ambient matches set point, and then for every click, which is a ½ degree, you get a low beep. So if you want 2 degrees below what the ambient is, keep pressing the button until you hear the double beep, and then use, it's 4 clicks essentially, and that will put you 2 degrees below ambient, because it's ½ degree per button press. So really nice feature. You've also now got a boost menu. So if all you do is walk up to it and press the circle button, you can see we're going through the boost menu there. So you can go through and you can change how long you want, whether you want a 1 hour, 2 hour, or 3 hour boost, and then you choose the temperature you want. A familiar flame symbol to show you that there is a call for heat. But from an installer's point of view, it's all about the load compensation with this. So if we go into the settings menu here, you've got your user settings. So that's really everything for your customer, where they're setting up different modes, manual mode, holiday mode, that sort of thing. Advanced user, that's going to be clock settings and things like that. In the installer settings, this is where you can go through and you can set what goes on. So you see that you've got the beep option there, but more importantly, you can go through and you can set the fuel type. So in the same way that we do with Wiser, where we can go through and we can set whether it's gas, oil, electric, or heat pump, this is the load compensation aspect, and this is what makes it Boiler Plus compliant, is the fact that we can go through and we can optimize the control algorithm here to suit the type of fuel you're using. So for instance, for gas, it's 6 cycles per hour. The hour is split up into 6 lots of 10 minutes, and the control works out how long in each 6-minute block it needs to run for in order to fulfill set point. If you're in oil mode, it slows it right down. So it's 3 cycles per hour. So 3 lots of 20 minutes. And again, same principle, works out how long it needs to burn in each 20-minute segment in order to maintain set point. Electric, 12 cycles per hour. So once every 5 minutes. And we have now optimized it for heat pump. So with a heat pump, you don't cycle it. It's that's certainly bad news to do with the heat pump. So in heat pump mode, it's just an on-off control. But this session is all about trying to maximize your customers' efficiency. If you replace a traditional bimetallic strip thermostat, or even an electronic thermostat like this, our RTS1 or an RTS4 with the new Digistat, you know, get the right version. You're really going to be able to drive their savings, because this is very much on-off control theory with an anticipator inside. This, you're actually tailoring it to suit to suit the fuel type you're using. And if you use the single channel wireless version, the RF901, or the 2290B, which is the mains wired version, they're also OpenTherm compliant. So you can go in here and you can change all of your OpenTherm parameters from within the installer menu. So really nice product. I did mention the 2-channel, and I do want to just cover that off, because this is a real winner for me, because what this allows you to do, if you've got a customer that's not necessarily particularly interested in going with smart, they just, you know, they've got this sort of arrangement where they've got an LP on the wall, you know, at 2 channels, so it's a conventional system with a hot water cylinder. Normally with these, if you've got an LP, you've probably got a dial thermostat like that. Now, an easy way that the customer can really drive their efficiency without having to do any changes to, you know, pulling wires in and that, is to swap out the LP with the receiver that comes in the RF902. So you can see that it's the same Digistat that you get with all of them. It's the same Digistat in all of them, or it certainly looks the same. Some will be wirelessly enabled, obviously, and the ones that come in the RF packs will be wireless. But they all look the same. But the receiver is the bit that's different. You can see you've got the 2 buttons on here, so you can take a 2-channel programmer like that. Same backplate, so it's the same industry standard backplate. All the wiring's the same. You can see on here that the pin out for that, if you look at the little diagram there, it's exactly the same wiring that you get on the LP. So you've got your hot water off terminal there on terminal number 1 if you're going to be fitting this to a Y plan and you need to energize the grey wire of the valve when there's not a call for hot water. All the same backplate, clips on. But what you've immediately done is you've given the customer a wireless thermostat, so they're no longer tethered to this one here, or that's a frost but they're no longer tied to the position where the wired thermostat is. So it's the fact that it's wireless means they can sight it where they want. It can go on the clip at the back, on the wall clip, or there is a table stand, so you can get it to sit on the table. But anyway, they can stick it wherever they want. But because of what I just showed you with the fuel type, you've now got some load compensation. So rather than, you know, the thermostat kicks in, it heats until the room's at that temperature and then turns off, and you have this big hysteresis, this big overshoot and undershoot. This is adding some load compensation, and all you've done is swap out a 2-channel timer with the receiver. Now, the room stat, the existing room stat, you will need to link that out, or you can just stick it up to maximum. So leave it set to maximum. The danger with leaving it to maximum is that somebody can turn it down, in which case they'll stop the call for heat on the Digistat. So it definitely, the preference is to wire it out and just link it out in the wiring center. But certainly it's a good thing to do. And you'll probably have noticed that your merchants have got some really good deals on at the moment. There's something in the region of 30% off the price of the new Digistat. Across all the range as well, so the wired versions, the wireless. Head over to our website and have a look at that if you want some more details on that. But yeah, really good pricing in the merchants at the moment, so it's a really good time if you haven't already tried the new Digistat to get involved with it. And again, you know, if you've got any questions, you can always ask me. You know, reach out on the group if you've got any questions, or indeed our customer services. I don't think I mentioned it. It's actually got Bluetooth connectivity as well, so you can, or your customer at least, can link to it locally using the Wiser Home app, and it just makes scheduling that much easier. Absolutely don't have to. There's no need if you don't want to go anywhere near the app, and certainly from an installer's point of view, you don't need to go into the app to set it up. It's very much there for the customer if they want to be able to just link across to it and, you know, sit in the comfort of their armchair and do their scheduling whilst they're within the property. They can do that. Doesn't need an internet connection. It's not a connected product. It's not rivaling Wiser, but it just makes the whole business of scheduling much easier because you can do it on the Wiser Home app. So really nice product, and it will, like I say, in the merchants now, some really good pricing on it. Right, quick check on questions. Somebody's asking here, do we have a solution for frost protection? Which actually is quite topical, isn't it? Well, we absolutely do, and that's why I prepped this, because this is our frost stat. This is an RTS3, and you know it's the RTS3 because it goes between 3 and 10 degrees. Now, what we actually do is a 2-stage frost protection. So let me go on to our website, and I'll show you on our website. We've got, if we have a look at products and then control packs, you'll see here, this is our full range of control packs. But we actually do a frost control pack, which is this is 2-stage frost protection. So this is using the air thermostat, the RTS3 that I just showed you, and the pipe stat, the PTS1. So that's PTS1 is going to go on the return near the boiler. So essentially, what we're basically saying, they're actually wired in series. So in order for there to be a call for heat, you would need both the air stat and the pipe stat to be calling. So pipe stat would call for heat because boiler's not been on for a while. Air stat will call for heat because ambient air temperature has dropped. Under those conditions, it's then going to give an output. So you're going to wire this in to fire, I would suggest, probably your central heating zone valve. Or you could do it to the hot water cylinder, but probably central heating, I would say, just so that we're able to get, some flow through the pipes. And then, so both of those calling for heat, that's going to kick the boiler on. And then if any one of them stops calling for heat, it will kick the boiler off. Now, what's going to stop it calling for heat is probably the pipe stat, because the return temperature is going to come up. You're going to be up above what you've set the pipe stat to be on the return temperature, and that's going to kick it off. So the idea of this, we're not looking to heat airspace here. What we want to make sure is we don't have any issues with pipes freezing. So if we just had the air stat, we would be waiting for the air temperature to come up above what it's set to, which is probably, and if that's in an area, say if it's boilers in the garage, you're not necessarily going to have a radiator in the garage, but you're going to want to make sure that the pipes in the garage don't freeze. So that's where you're going to locate the frost stat, the air sensor, the RTS3, but you can't be waiting for that airspace to come up to temperature because there's no emitter and there's no radiator. So that's where it would, if you only had the RTS3, it's going to kick the boiler on and it's going to be on essentially forever. But that's why you've got the PTS1 on the pipe stat on the return. So as soon as we're getting hot water back from the boiler on the return pipe, you don't have to set that too high. Maybe set it at sort of 30 degrees. That will then kick it out. So we're just kicking the boiler in. We're circulating water around the system. We wait until the hot water gets back to the boiler. It doesn't have to come up to its normal operating temperature. It's just so that we're able to then get some flow going around the system and it stops the pipes from freezing. Right, little brief interlude on that based on that question. Last thing we'll look at is, in the interest of driving efficiency, is WISER. Always give WISER a mention because it's the multi-zone capability, multi-room capability of WISER using the rad stats that really can drive some efficiency. So the important thing with WISER is you need to get the WISER hub installed. So regardless of whether you want to have multi-zone capability or you just want to have one room thermostat controlling the whole property, the important bit to get installed is the WISER hub. Once that's in, your customer is then at liberty to do whatever they want with it. So if they just want to have this arrangement here, the whole house controlled by one central point, they can do, and that's exactly the same as the new Digistat. But by having the WISER hub, we can then start subdividing the house into multiple zones using the WISER rad stats. Now, remember, with these, they come with 2 adapters. They come with the Danfoss RA adapter. So if you've got this Danfoss valve, you can use the RA adapter. Let me get rid of that so you can see this a bit clearer. You've got the RA adapter, which requires the Allen key to screw it on. And then once you've got the adapter onto there, you can screw the WISER head on. Or you've got the 2-part adapter, this one here, which is suitable for our valve bodies. So let's just use one of these auto balancing bodies here. That screws onto there, and then you can screw the WISER head onto the valve body. So really useful. You don't need a drain down or anything, but you can have up to 32 of these on a system spread across 16 separate zones. And what I'll actually do now, let me show you some statistics. So this is independent statistics that we've got from 𝗵𝗲. Here we go. So this is some research that was done by 𝗵𝗲. So it's not us telling you this. This is independent research on the benefits that you can get with Wiser. And what it really boils down to is around about 30% is what your savings you can make by having Wiser. Now that splits out by having every room zoned with a Wiser radiator thermostat. And you've got things like away mode. So, as soon as you leave the house, you can either automate it using IFTTT to turn your heating off or set your heating back. And you've got eco mode where we're bringing in weather data based on your postcode to really optimize, the heating, so that as the weather gets warmer, as we progress towards summer, your heating will go off that little bit earlier. So if you lump all that together, it can make a saving of up to 30%. Now, that 30% based on current energy cost is something in the region of about 500 to 550 quid for a typical property. So the payback, this was always the question I used to get asked with Wiser is, what's the payback? If I install a radiator on everybody's or if I install a radiator valve or Wiser Radstat on every radiator in the property, what am I going to be? What's it going to cost me? When am I going to get it back? Well, it's going to cost you probably 500 or 600 quid to do every radiator. You don't have to do it all at once. Wiser is very much a modular system, so you can build it up over time. But you can see here, you're getting it paid for in the first year by the savings it's made, and then for every subsequent year, you're really making some good savings. So it's a really good thing to do. Pretty much talked about Wiser a lot recently, so I'm not going to cover it too much. But whilst we're talking about the subject of how we drive efficiency for your customer, it's exactly the same. It's the same story. The Wiser hubs sit on the industry standard backplate. You buy the appropriate hub. So this is a single channel. So this would be for a combi. If you had a 2-channel heating and hot water, you'd buy a Wiser Kit 2. And we've also got the 3-channel, but really easy to upgrade. Isolate the power. Ode control off of its backplate, and the new control in. And if you've got a wired thermostat, just link it out in the wiring center. Right, last thing that I want to talk about with you is making sure that you are 9 Degree Network members. Now, you all should be, hopefully. Certainly, if you've joined if you've joined the Facebook group, which you obviously have because you're watching this, you must have heard about the 9 Degree Network. So I just want to cover that off a little bit to make sure that you're getting the benefits that you should be from being 9 Degree Network members. So here's the login page. When you log in, this is what you get to. 9 Degree Network is pretty much split into online training and the priority shop. The online training is where you get all of your modules. So there's new modules going up here periodically. Stuff on Wiser. So if you need to refresh your memory on how to install Wiser, or you want a bit of a deeper dive into our TRVs, or indeed the auto balancing, it's all there. There's the latest one that went up is the motorized valve. That's pretty much a fault finding. I heard how to bench test motorized valves. So you've got the training side of it. You've also got, if I can remember how to use an iPad, you've got the priority shop. So here, this is where you can buy stuff, fairly discounted prices. You're limited to how much you can buy because we're not trying to compete with the merchants. Your route to getting our products is always through your usual distribution, through your merchants. But if you want some oddball things like the TRV gland seals, or indeed that tool that you saw me using, the balancing key, that's available there. But there's also now Wiser rewards. Let me whiz to the end of this and I'll show you the slide on the Wiser rewards. If I can get my ducks in a row here. Here we go. So Wiser rewards. So we've got a reward scheme, and essentially you get rewarded for the more kits that you register. Now, I say register because you do need to go onto the 9 Degree network and register your products. Now, you should be doing this for all of your Drayton products anyway, because any Drayton product that you register is eligible for a free 5-year extended warranty. So really good, and this is the really good selling point for your customers. You can say that if you fit whatever it is, whether it's TRV4s or if it's an LP, if you register it on our 9 Degree network, you get the extended warranty. But from a wiser point, for every kit that you register, for every 10 kits that you register, you'll get a free kit. So that's a pretty good deal. And then if you're prolific, if you're fitting for every 30 kits that you fit, you get a free multi-zone kit of your choice. You get 4 radiator thermostats, you get a Wiser plug, and you get a 50 quid Amazon voucher. So really worth you not only fitting Wiser to drive your customers' efficiency and really improve the efficiency of their heating system, but you get the kickback that you register it, you get 5-year warranty, but also as they start to tally up, you'll be eligible to get the rewards for fitting 10 kits and then for fitting 30 kits. You also, like I said, you get access to our training module, and you get the pricing perks from the online store. Right, last check to see if there's any questions that have come in other than the one I did about frost. And I'm not seeing anything, so we're probably into the last 30 seconds now. Thanks for joining me tonight, guys. This is the penultimate one of the year. So we'll have another one in December, and then I'll be off for the Christmas break, as hopefully you will too. So what's billed for next month is a bit of a customer service mashup, so a bit of a roundup of the year to see what's the big hitters that have been coming in over the last few months and answer your questions. But it's a good opportunity now, a bit of a heads up, if there's anything you want to see in that last one of the year, and if there's a lot of interest, it can run for longer than the half an hour. But anything that you want to see about any Drayton product, pop it in the comments, post it on the group. Anything that you want to see, get it in, and I'll build the session around that. Last check of questions. Don't see any. Thanks for joining me, guys. Have a lovely rest of the week, and enjoy the rest of your evening. And I'll look forward to catching up with you on the next one. But for now, see you later.